In this video, I will show you how to solve polynomial inequalities using sign charts. I'm going to refer to the left side of the inequality as f of x. To make a sign chart, we need to know where f of x is equal to 0, and we need to know where f of x is undefined. However, a polynomial like this one is defined everywhere, so we don't have to worry about that part yet. In factored form, it's easy to see that f of x will equal 0 when x is equal to 4 and when x is equal to negative 3. We simply set each factor equal to 0 and solve. We can now make a sign chart by putting these critical values on a number line. Put the critical values across the top of your sign chart like this. Make a row for each factor in your function. Next, we need to determine whether these factors are positive or negative in each interval. X minus 4 equals 0 at x equals 4. It will be negative to the left of 4 and positive to the right. For example, if you pick any value less than 4, let's say 0, we would have 0 minus 4, that's a negative. If you pick a value bigger than 4, like let's say 5, you get 5 minus 4, that's a positive 1. Similarly, x plus 3 equals 0 at negative 3. This factor is negative to the left of negative 3 and positive to the right. What about the overall sign of f of x? In the first interval, we would have a negative times a negative. Remember, these factors are here and here. A negative times a negative is a positive, so that's the overall sign of f of x in the first interval. In the middle interval, we have a negative times a positive, which is a negative. And in the last interval, a positive times a positive is a positive. We are looking for the values of x that will cause this function to be less than 0. So the solutions will be in the interval where f of x is negative. This may look like an ordered pair, but this is really interval notation. This says that the solutions are between negative 3 and 4. The fact that we use parentheses indicate that negative 3 and 4 are not included in the solution set. If the problem had said the function is less than or equal to 0, then we would have used brackets instead of parentheses. But this is the answer to number 1. Problem number 2. We start by asking ourselves, where is f of x equal to 0? So this is already in factored form, so we can see that f of x will equal 0 when x is equal to positive 4 from the first factor, and where x is equal to negative 1 from the second factor. Again, put these critical values in order on a number line across the top of your sign chart. Make a row for each factor of your function. Now we decide whether these factors are positive or negative in each interval. X minus 4 equals 0 at x equals 4. This factor will be negative to the left and positive to the right. X plus 1 equals 0 when x is equal to negative 1. This factor will be negative to the left and positive to the right. In the first interval, the overall sign of f of x will be positive because a negative times a negative is a positive. In the middle interval, f of x will have a sign of negative because a negative times a positive is a negative. And of course, in the third interval, f of x will be positive because a positive times a positive is a positive. The solutions are the values of x that will cause this function to be greater than or equal to 0. So the solutions will be in the intervals where f of x is positive. However, we will also include the endpoints of negative 1 and 4 in the solution set because we want the values that cause the function to be not only greater than, but also equal to 0. And as we discussed, f of x equals 0 at 4 and negative 1. So this first interval runs from negative infinity to -1. And we will show that -1 is included in the solution set using a bracket. Because we have two intervals, we will put the union symbol between, and the final interval goes from +4 to infinity. Again, using a bracket to show that +4 is included in the interval because we want to include values of x that cause the function to equal 0 this time. So this is the final answer for number 2. I encourage you to pause the video and try number 3 by yourself. We start by asking ourselves what values will cause f of x to equal 0. Setting the first factor equal to 0, we get x is equal to 1. Setting the second factor equal to 0, we get x is equal to 4/3. Put the critical values across the top of your sign chart like this. Now let's decide whether each factor is positive or negative in each interval. X minus 1 is equal to 0 at 1. It will be negative to the left and positive to the right. 3x minus 4 is equal to 0 at 4/3. It will be negative to the left and positive to the right. The overall sign of f of x will be positive in the first interval because a negative times a negative is a positive. In the middle interval, f of x will be negative because a positive times a negative is a negative. And in the final interval, f of x will be positive because a positive times a positive is a positive. Because we are looking for values of x that will cause the function to be greater than or equal to 0, the solutions will be in the intervals where f of x is positive. This first interval runs from -infinity to 1. -infinity to 1. We will use a bracket on the 1 to show that 1 is included because that is a value that causes f of x to equal 0, and we want values that cause the function to be not only greater than, but also equal to 0. So bracket there. Union 4/3 to +infinity for the last interval. So that's it for number 3. Number 4 has 3 factors to it. So where does f of x equal 0? Looking at the first factor, we have x is equal to -8. From the second factor, we get x is equal to -2. And from the third factor, we get x equals +3. Place your critical values in order across the top of your sign chart and make a row for each factor in your function. Let's decide whether these factors are positive or negative in each interval. X plus 8 equals 0 at -8. It will be negative to the left and positive to the right. X plus 2 equals 0 at x equals -2. It will be negative to the left and positive to the right. X minus 3 equals 0 at x equals 3. It will be negative to the left and positive to the right. To decide whether f of x is positive or negative in each interval, you can just focus on the negative signs. If you have an odd number of negatives, that is going to cause f of x to be negative. If you have an even number of negatives, f of x will be positive. So since we only have one negative in the third interval, f of x will be negative. Obviously, if we have all positives, that makes f of x positive. In this case, we are looking for the values of x that cause f of x to be greater than or equal to 0. So the solutions will be in the intervals where f of x is positive. As we write the solution set, we will use brackets for these endpoints because these are the values that cause f of x to equal 0. And we want the values that cause f of x to be not only greater than, but equal to 0. We will show that -8 is included by using a bracket, just like -2 will be included. So that's this first interval from -8 to -2. Because we have more than one interval, put the union symbol in between. The final interval goes from 3 to infinity. So use your bracket, 3 to infinity. So that's it for number 4. On number 5, in order to find the critical values, we first need to factor. X squared is x times x. 4 is 1 times 4. To get a positive 5 in the middle, we need a plus and a plus. Now we can ask ourselves, where will f of x equal 0? And that will be at x equals -1 and at x equals -4. So we put the critical values on a number line across the top, and we decide whether these factors are positive or negative in each interval. X plus 1 equals 0 at x equals 1. It will be negative to the left and positive to the right. X plus 4 equals 0 at -4. It will be negative to the left and positive to the right. The overall sign of f of x will be positive in the first interval because this is a negative times a negative. In the middle interval, f of x has a negative sign because this is a negative times a positive. And of course, in the last interval, f of x will be positive because we have a positive times a positive. Because we are looking for values of x that cause the function to be less than or equal to 0, the solutions will be in the interval where f of x is negative. In interval notation, we write -4 to +1. We will use brackets on the -4 and the 1 to show that -4 and 1 are included as solutions because these are values where f of x is equal to 0, and we are looking for values that cause f of x to be less than or equal to 0. For number 6, we again need to factor. X squared is x times x. 49 is 7 times 7. To make a -14x in the middle, we need a -7x and another -7x. Notice that -7 times -7 is +49. The critical values will be where f of x is equal to 0. We only have one critical value this time, and that's where x is equal to 7. There are two ways you can make this sign chart. One way is to write a row for the x minus 7 and another row for the other x minus 7. In this case, x minus 7 equals 0 at 7, so this factor will be negative to the left and positive to the right. Of course, the other factor of x minus 7 does the exact same thing. What about the overall sign of f of x? In the first column, we have a negative times a negative, so that's positive. And a positive times a positive is again a positive. So that's one way you can make the sign chart. The other way is to recognize that x minus 7 times x minus 7 is x minus 7 squared. So in this way, we only need one row. Notice that if you square something, it's going to be positive no matter what. So that means f of x will be positive in both intervals, which is the same thing we got last time. Since we want values of x that will cause this function to be greater than or equal to 0, the solutions will be in both of these intervals where f of x is positive. And in fact, because we are including both intervals, and we are even including 7, because 7 is where f of x is equal to 0, and we want values where the function is greater than or equal to 0. So really, guess what? The solution set is going to be from negative infinity to positive infinity. Right? We have negative infinity to 7, we have 7 to infinity, and we have 7 itself included. So that's all real numbers. Just for fun, imagine a problem that was exactly the same as number 6, except for this time, we're looking for the solutions that cause the function to be less than or equal to 0. Since f of x is positive in both intervals, Does that mean there is no solution? Not exactly. There is exactly one solution. Remember, we want values that cause the function to be less than or equal to 0. F of x does equal 0 at 7. So 7 itself is a solution, the only solution.